Hey everybody, welcome to the Daily Space Weather. We've got a growing sunspot, increased likelihood of solar flares, coronal mass ejections, and lots more to cover. So here we're looking at a colorized magnetogram and 171 angstroms ultraviolet light spectra from the Solar Dynamics Observatory. And we've intentionally overlapped the beginning of the video here to show the edge of the sun as well as the Earth scale. So this is the sunspot down here, sunspot 2857. It has grown since yesterday, thereby increasing the likelihood of large solar flares. There is also a coronal mass ejection watch in effect, and this is stereo A's coronagraph here, as well as the LASCO C3. And just to give you some perspective on that, here's our diagram of Lagrangian points. When an astronomer says L1, he means this. That is where the SOHO LASCO C3 is located. If an astronomer says L5, they mean out here, putting the Earth to your right from the perspective of stereo A. And if you're a new viewer, please realize that we only forecast coronal mass ejections in this area. The Earth-facing side of the solar disk, we don't forecast them over here, only over here. So once again, stereo A is located at Lagrange point 5. The SOHO is located at Lagrange point 1. That's where this C3 coronagraph is viewing from, right in between Earth and Sun. There's also a interesting plasma filament here. This is 193 and 211 angstroms. This up in the northeastern limb. Great view there of this little filamentary plasma dance going on. Spectacular imagery there from the Solar Dynamics Observatory. Here's sunspot 2857 in 171 angstroms alone. More spectacular imagery here. If you're looking at your phone while you watch our videos, just watch the videos instead. Here's 304 angstroms and 171 angstroms. That's ionized helium and ionized iron. We've even got one more here. This is 131 and 94. Some more imagery of the full disk view toward the end of the video. The radial flux has come up one solar flux unit to 74. Here's the 1-year chart of the solar radial flux. The black line here is the 10.7 centimeter radial flux. Oh, we're up to 75. Okay, 75 solar flux units. No solar storms forecasted. There are some coronal holes. We'll talk about those a little later in the video. Global seismicity has calmed down. Here's a 90-day bar graph. And sadly, the death toll in Haiti has gone up to nearly 1,300. Here's some imagery of that. Following that major earthquake, 7.2 magnitude, 7.1, something like that. So lots of people missing, lots of people injured, lots of buildings destroyed. Rescue efforts continue on the Isle of Hispaniola, especially the eastern side. The western side over here. That's the location of that. And here's another article from BBC about it. French Gothic church here completely lost its roof. Death toll now reported at least 1,297. So fortunately, seismicity has calmed down a little bit here. And let's see what's on the list. South Sandwich Islands continue to shake. And we still see aftershocks at Haiti as well, like that 4.7. Lots of quakes in the high 4 and low 5 range around the South Sandwich Islands region. That's the southernmost portion of the Atlantic Ocean, right near the Southern Ocean. Small deep quake at Chile. It's a 4.5 at 110 kilometers estimated depth. So a little bit of a respite here for seismicity. Here's one in Russia, a 5.0. Armenia also seeing a 5.0. Now, what is this one here? Tajikistan, a 5.1 at Tajikistan in the past 24. Largest quake of the past 24 was an aftershock at the South Sandwich Islands region at a 5.8 magnitude. Let's take a look at volcanoes here on volcanodiscovery.com. So Karimsky still exploding, producing an 11,000-foot ash plume over the Kamchatka Peninsula. Also Shivaluch, 15,000-foot ash plume on that same geographic location, the Kamchatka, the extremely desolate and cold Kamchatka Peninsula. Cherinkatan, exploding now in the northern Kuriles Islands. 15,000-foot ash plume there. Suwanosejima, flight level 060, 6,000-foot ash plume produced over the Ryukyu Islands. Mount Merapi, over the central Java island of Indonesia. The Indonesian island of St. Java, I'll say. Explosive activity there at Merapi. Flight level 120. It's a 12,000-foot ash plume, 14,000-foot ash plume over Semeru. On that same island there, East Java, Indonesia, a volcanic hotspot. Samisa Pochnoi and the Aleutian Islands now exploding. Flight level 100. It's a 10,000-foot ash plume. Fuego exploding, 15,000-foot ash plume over Guatemala. Nevado del Ruiz. Volcanic ash has dispersed in Colombia, fertilizing the soil. Revenador exploding, flight level 160. It's a 16,000-foot ash plume over Ecuador. Sabancaya exploding, 26,000-foot ash plume over Peru as a result of that. Sporadic emissions from Nevado State Chilean. Please don't pole vault the caldera. It could be unfortunate for your health, and we need the views. And we'd like for you to tell your friends and foes about our channel and our own website, smAsho.com. On the website, you can find links to our Redbubble shop. And here's a quick little teaser of what you can find there. Today's featured product is Mensa. Make Earth not suck again. Have you noticed Earth's been sucking? Well, I certainly have. Smash staff agrees. So, Mensa. Make Earth not suck again. It's up to you. It's part of the purpose of our channel, making Earth not suck again. Some YouTube channels are making Earth suck, or perhaps making Earth slightly worse. We're trying to do the opposite. So help support us with a Mensa hat. You can also get a ton of other different products with that design. You can find links at smAsho merch. Link here on the homepage, smashomash.org, will redirect you to smashomash.com. And welcome everybody to the Neo Renaissance. And helping us to welcome you to the Neo Renaissance are our patrons. Thanks again, patrons. Patreon.com/smashomash. Consider funding our operations, which are going to expand in the month of September. More on that later. We'll make a video all about it. Next, back to the GOES 16 sun-facing suite of instruments. We saw 2 minor B-class increases in the solar X-ray flux. Nothing to write home about, just 2 minor B-class flares that are happening in the past 24 hours. No spikes in the proton flux, no coronal mass ejections. We would have forecasted it or probably told you ahead of time to expect those, although sometimes they do show up because of relativistic particles in only as little as a half an hour following a major flare. Here's the GOES magnetometer over the past 3 days, and we were actually incorrect yesterday about the current sheet. There was some indecision looking like it was happening here, but I'm starting to think it's happening as we make the video. So when you see these spiky sawtooth patterns in the GOES magnetometer, it can mean various things, changes on the sun itself, or major streams of plasma in between Earth and sun. This was a heliospheric current sheet switchover. So here we're looking at the heliospheric current sheet in terms of polarity, North Pole shown in green, South Pole shown in red. The data only 1 hour and 18 minutes old today, still not showing the Earth in this little South Pole current sheet. So that was kind of a surprise. I was incorrect about that one. Update your live journal, as you won't find me being incorrect particularly often. Although I do like being incorrect because it causes me to change my understanding of the physics somehow in most cases. Anyway, there's the top view ecliptic plane field plot, the latest image there from 56 minutes ago. Here's the line of sight ecliptic plane field plot. We are expecting Earth, at least briefly, to be in a South Pole current sheet. The crossover possibly happening as we make the video. Here's a line of sight coronal hole plot, and once again I would remind our viewers that we are forecasting a major increase in coronal holes here over the next 60 days. So we can see two transequatorial coronal holes here. There's one in the south right about here. There's one in the north right up here. And I would expect a coronal hole wind stream from that northerly oriented coronal hole there, that green coronal hole. I would expect a coronal hole wind stream from that in 2 days. So we can expect a minor enhancement in the solar wind. You know, a coronal hole wind stream, an enhancement in the solar wind density followed by a decrease in the density and an uptick in the speed, the signature of a coronal hole wind stream. Here's the latest image. And actually, this South Pole-oriented coronal hole is not transequatorial yet. We'll be keeping an eye on that. And when I say eye on, oh, well, the pun is intentional. Next, the solar flare probability, computerized imagery here, and the detected sunspot groups showing you sunspot 2857, indeed beta class, beta gamma class. And you can see the likelihood of solar flares coming up here, as we said earlier in the video. No surprises to our regular viewers there. And thanks to our regular viewers. Next, geomagnetism on a global scale. The planetary K index is a measurement of that. Current conditions, KP of 1, as the most recent weak coronal hole wind stream has largely subsided. Next, we'll look at the real-time solar wind data here. You can see indeed the solar wind now down to 438 kilometers per second. Solar wind density only 4.97, just under 5 protons per cubic centimeter here. Phi angle's been steady over the past 12 hours. And the BT-BZ fairly uneventful as well there. Just a minor -1 for the BZ and a 5 nanotesla for the BT, the total solar field. Next, the Geospace magnetosphere movie showing magnetohydrodynamic pressure as modeled by the Space Weather Modeling Framework for the past 4 hours. And you see a minor subsiding there of the pressure, especially on the bow shock side, the side facing the sun, which would be to your left of your screen. Magnetotail would be to the right of your screen. Ground magnetic perturbations are next. Geospace delta B, we showed you the sun's B field. Here is the Earth's B field, or at least changes in it. And when you see the word delta, or if you see a triangle in a scientific equation, it means change in. That is what the delta Greek letter is used for. Anyway, nothing too exciting going there on ground magnetic perturbations. Next, going out a little farther from home here, here's a diagram of the solar system. Keep in mind, this is not to scale in any way. It's just showing the locations of things. We'll advance this 1 week. And the full moon will be on the 22nd. Here's a star chart. It's from in-the-sky.org. And Jupiter's just setting here in the Lehigh Valley as the sun rises. At opposite ends of the horizon, we see the largest planet and the closest star. One setting and one rising, respectively. We've also drawn in the galactic plane here, and the ecliptic, the path the sun will take across the sky. Continuing on to our brief cosmology segment, which is integrated into today's daily space weather video. Now, yesterday we talked about cosmic rays. If you want to hear about that, watch yesterday's daily space weather video. The cosmology segment was integrated. There is also a playlist for cosmology segments, which contains over 200 videos. youtube.com/smashamash/playlists. Perseids. It's the astronomy picture of the day. You can find it yourself at apod.nasa.gov. apod.nasa.gov showing another Perseid, as well as some sprites here over the top of a thunderstorm. You can see these red jellyfish up here, or red sprites, or whatever you'd like to call them. Great composite imagery there from Daniel Corona. Perhaps an ironic name. He's got the ground, he's got the sky, he's got the galaxy, he's got sprites, and he's got a Perseid, as well as a nova. How about them apples? Today's random number is nothing. We're not going to show you anything, but if you want to look up your favorite hard X-ray sources, head to the Neil Gorell Swift Observatory. You can find things like Sagittarius A star there if you like, and look at the hard X-ray output from it and realize that it has nothing to do with the activity of the sun. And this one goes to Robert La Follette. Yes, he keeps talking about campfires on the sun. Well, there's been an article about it recently, just this year in May, about campfires offering the a clue to the solar heating problem. And we've actually sent a link to our patrons already about that, as well as the imagery of the anatomy of the sun according to the ESA. Maybe check that out. Maybe consider becoming a patron for all kinds of information nobody else gets to see at patreon.com/smAshomash. Anyway, if you want to read about that, you can just pause the video or go to SciTech Daily. Campfires on the Sun. That's our cosmology segment. It was short. It was sweet, because we've got lots of stuff to cover today. So here is the charging environment around the planet. Electrons can charge up satellites. They aren't currently doing so. No charging hazards. Here's the 1-year chart of the electron flux. That's from solon.info/solar if you want to look it up yourself. Here's the 3-day chart of the electron flux, and it's actually still cratered here. We are expecting an increase soon before the next before the next coronal hole wind stream arrives. So sometime around here, we're going to see this come back down, because coronal hole wind streams crash the electron flux. By the way, that's measured at the F ionosphere layer at about 300 kilometers of altitude by the GOES-16. Anyway, that's the NOAA forecast. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of Earth Van Allen belts. Distances are shown here in miles. And here's the total electron content. It's the total air column up to where a GPS satellite would be located down to your handset. And most GPS errors occur around the equator at noon. Nothing crazy happening here on the total electron content forecast. Here's another diagram of the atmosphere, because we're going to show the ionosphere next. The F layer located at about 300 kilometers of altitude. And here it is. Each little color blob here showing you 1 megahertz variation in vibrational frequency. Megahertz are millions of vibrations per second. There's a lot of stuff going on in terms of chemical reactions at the bridge between Earth and space. And we see some anomalies happening in the northern hemisphere. Once again, some low-frequency anomalies, certainly. Let's just bring up the latest image and show you the anomaly map. There's the latest image from 1030. And we see some low-frequency anomalies in the Pacific as well. Here's the anomaly map showing you the anomaly in megahertz departure from the 30-day median. You can see those red blobs in the northern hemisphere. Those are our low-frequency anomalies. Blue blobs are the high-frequency anomalies. And keep in mind, at the times of the equinox, the Earth is more affected by incoming solar protons, magnetic field changes, and so on from the sun. Here's the latest image on the anomaly map. So there's the current data, 10:30 Universal Time, and there's the current anomaly map. Similar anomalies to yesterday there in northern Canada. And once again, all of our daily space weather viewers are invited to join us on Twitch, twitch.tv/smAshomash. We regularly view videos that we originally streamed live to Twitch, twitch.tv/smAshomash, like our meteorology segments. Today's will be there before it appears on YouTube or BitChute. So if you're viewing the videos on YouTube or BitChute, consider becoming a follower over on Twitch, twitch.tv/smAshomash. Probably the world's best live streaming platform. And if you're only watching our daily space weather videos, make sure you check out our meteorology segments as well. They are spectacular. Once again, today talking about climate change. And thanks to our BitChute viewers. If you're viewing the videos on BitChute, make sure you subscribe on YouTube, as you're missing most of the content. YouTube.com/smAshomash, the main source of our video content. Thanks to our viewers over there. Here come bonus features. First, the Lermonth, Australia hydrogen alpha imagery. So here's this filament that we showed you in close-up earlier from the SDO. It's still up there. It could eject. Another prominence down here as well. We call them prominences. They're called filaments. There's various names. You could call it plasma. And you can see it's quite bright in hydrogen. This imagery here in 6,562.8 angstroms, hydrogen alpha. It's the emission spectra of hydrogen, ionized hydrogen, by the way. So here's a GOES-16 SUVI imagery. which shows you all of the features. Again, likelihood of coronal mass ejection still quite high, folks, which is why our coronal mass ejection watch is still in effect. If you see it, switch it to a warning. That means that it's actually occurring. And yeah, so there are all the features. Lots of filaments here in between the Earth and Sun. Lots of filaments hanging off of both the north and southeastern limbs. Likelihood of solar flares significantly higher now with Sunspot 2857 and its continued growth. Here's the latest imagery of it. And you can see it's quite well defined. It's actually grown here since I got out of bed this morning. So that's continuing to intensify. Here's the latest colorized magnetogram. Sunspot 2857. It's what to keep an eye on. Speaking of ions, here are some more. Iron ions. 2 different states, in other words, different numbers of electrons in their shells here. 131 and 94 angstroms. Composite imagery from the Solar Dynamics Observatory. Just splentacular. And so lots of stuff forecasted here in today's video. Thanks for tuning in, folks. Here's one last full disk view. 211 and 193 angstroms. More iron. More iron here. Ionized iron and the emission spectra of it in ultraviolet. Coronal holes to increase, solar flares to increase, coronal mass ejections likely to happen. And may that solar wind be at your back.